Okay, so here's my solution to 1996 AIME Problem 5. Suppose that the roots of x cubed plus 3x squared plus 4x minus 11 is equal to 0, and a, b, c are the roots. And then the roots of x cubed plus rx squared plus sx plus t is equal to 0, and the roots are a plus b plus c, and c plus a. Find t. So basically for this problem, what you have to use is Vieta's formulas. So here is my demonstration of this. So basically, for Vieta's formulas, if you're given a polynomial x cubed plus rx squared plus sx plus t is equal to 0, and a, b, c are the roots, then what you can do is a plus b plus c. So the sum of the roots is equal to negative r over the coefficient in front of here. So it's basically the negative of this coefficient divided by this coefficient. And the pairwise sum of this, the pairwise double sum, is AB plus AC plus BC is equal to S divided by this coefficient. Now this is positive. Remember this is positive. So this is this, the basically when you do the sum of the roots, it's going to be negative. The r, it's going to be negative r. It's always going to be negative in front of that. And then you're going to alternate. So you're going to do negative, positive, and so on. So for S, for example, for the pairwise sum, it's going to be positive. And then when you do the multiplication of the roots, it's going to be negative again. So here, in this case, you have the sum is negative r over 1, which is negative r. Pairwise double sum is s over 1, which is s. And then the multiplication of the roots, the product of the roots, is negative t over 1, which is just negative t. So for instance, for this polynomial, it would be the sum is 5, the pairwise double sum is 4, and then the product is negative 2. Now back to the problem. First, we'll write out these equations for both the polynomials that were given. So for the first polynomial, for instance, the sum is going to be negative first. Remember that. So if you go back to the problem, so it's going to be negative in front of the 3, and then positive, and then negative. And same for this other polynomial. So negative in front of the r, positive in front of the s, and the negative in front of the t. So here we would have a plus b plus c is equal to negative 3. The pairwise double sum is 4, and then the product is 11. Okay, so for the second polynomial, these are the equations for the second polynomial. So we would just do the sum of the roots, and the roots here are a plus b plus c, and a plus c. So the sum of the roots would be negative r. The pairwise would be s, and then the multiplication would be negative t. Okay, so we're trying to ultimately solve for t, right? So t is right here, and you want to use these equations because these equations have these set of equations have the numbers, and you're trying to get the solution in terms of numbers. So what you would try to do is substitute these equations. So for instance, what I did was I used the first equation and I substituted it right here into this last equation because this involves t, right? So I would do negative 3 minus c. This is for a plus b. So a plus b is equal to negative 3 minus c if I bring the c on this side. So a plus b is equal to negative 3 minus c. And I repeat that for b plus c and c plus a using the same first equation for this first polynomial. So, and then I get these three equations is equal to negative t. Then I just expand out this equation, and then I get this negative abc minus 3ac minus 3bc minus 9c minus 3ab minus 9a minus 9b minus 27 equals negative t. Obviously, this is not structured the optimal way, as I could like put the negative 9c minus 9a and minus 9b together, but you get the idea. So then what I do is I just try to use the rest of these equations here to try to get my final answer in terms of numbers. So negative ABC, for instance, would be negative 11. And then what I would do is negative 3AC minus 3BC minus 3AB. I could group these three terms together since my pairwise sum here is 4. So that's exactly what I did. I did negative 3 times this pairwise sum minus 9 times a plus b plus c, which is using this, to try to group the negative 9a minus 9b minus 9c together, and then negative 27. So basically what I'm trying to convey is that I use these equations to try to get my final answer in terms of numbers, and I use this last equation. I don't even need these two equations above this negative t equation, because I only care about t for this problem, right? Yeah, it's asking for t, so I don't really need to know about r and s. I just need these numbers, and then I need the t equation. And then if I simplify this further, as you can see right here, I get negative 23 equals negative t, and then t is equal to 23. So that is my final answer. If you think that there are any problems or errors with my solution, you can reach out to me so that I can correct those issues. Thank you so much.